Good evening, ladies and gentlemen. I'm very sorry for this delay on our last session of the day. And the session is going to be on exploring innovative applications of green hydrogen, new frontiers, and use cases. All right. We are really privileged to have our eminent speakers in the panel this evening along with us. And I would like to invite them on stage at the dais, one by one. Dr. Ashish Lele, Director, National Chemical Laboratory. Dr. Lele holds a PhD in chemical engineering from the University of Delaware, USA. He has authored 75 research papers in international peer-reviewed journals and 6 patents. Dr. Lele is a recipient of Shanti Saurabh Bhatnagar Award in Engineering Sciences in the year 2006. Ladies and gentlemen, can we have a big round of applause? Mr. Anup Shapeti, Senior Technical Manager, INOX. We're really very privileged to have you along with us, sir. Mr. Anup has over 11 years of experience in the field of cryogenic storage and associated equipment. He has worked in various roles, including production, design, new product development projects, suppliers, vendor applications, sales, and marketing. Currently, he is involved in sales application for LNG vertical with a primary focus on developing LNG fuel tanks and LNG dispensing stations. Ladies and gentlemen, join me welcoming Mr. Anup Shapeti, please. Now, I would like to invite Mr. Raj Sawhney, CEO, CVS Strategic Partners. Raj Sawhney is the CEO in Clearview Strategic Partners, an energy insight firm that provides market analysis and strategic consulting for clean energy industries in Global South. Ladies and gentlemen, presenting to you Mr. Raj. Ladies and gentlemen, it is my privilege to invite the dais Mr. Bidyut Chakraborty, Vice President, Business Development, Green Hydrogen Business, Sembcorp, India. Bidyut has over 27 years of work experience in the power industry, and he has played a key role in the execution of mega power and industrial projects. He has helped Sembcorp in completing its first supercritical technology-based thermal power plant in Lele. He has been instrumental in opening up cross-border power cells opportunities in Sembcorp. Ladies and gentlemen, presenting to you Mr. Bidyut Chakraborty. It is my privilege to invite Mr. Gautam Reddy, CEO, Greenko. Gautam Reddy is the Chief Operating Officer for the new energy business at Greenko. He is leading the group foray into the green molecule business, including green hydrogen, green ammonia, and others. Previously, Gautam was the Managing Director of Schammelberg, South Asia. He has over 20 years of upstream oil and gas sector experience. Ladies and gentlemen, presenting to you Mr. Gautam Reddy, CEO, Greenko. I would now like to invite our moderator for the session, Mr. Vivek Bhardwaj, Objective Lead, SAREP. Vivek Bhardwaj is a green hydrogen and energy storage specialist at USAID SAREP program. He has done feasibility projects for green ammonia and fertilizer manufacturer and has been involved in hydrogen policy at state level. Ladies and gentlemen, presenting to you our moderator, Mr. Vivek Bhardwaj. And of course, along with that, we will move on to our report launch.
Thank you, everybody. What we hope to be an interesting session for the simple reason that today you will hear a lot of really good discussion about production of hydrogen, its challenges because of its high price. You will also hear about biogenic routes where people are able to reduce the price of hydrogen. You will hear about the offtake of hydrogen in mobility in various sessions. And for us, I believe we have a slightly more challenging issue at our hand, which is if India is to do the 6 million tons of green hydrogen, then what are those other innovative applications where we can deploy green hydrogen? And part of this initiative is this report, which is being done by USAID SAREP, which we are pleased to launch now. And just to give you a very quick introduction, we all have done a plethora of research on transportation. We talk about trucks, which will run on hydrogen. But there are other areas in India which are specifically to do with agriculture, mining, and construction, which is basically flying under the radar. Agriculture contributes to 7 to 8% in agricultural activity on tractors. Construction and mining have even more challenging roles because there is a 12-hour intense duty cycle in which you will use haul trucks in mining and you will use excavators to dig the earth. So really the question is that what are those pathways which we can apply to these three areas in a way that is techno-commercially viable? You can't use everything in a farm. I mean, can you imagine giving compressed hydrogen cylinders in an agricultural or a rural economy? So in this study, we have tried to reduce that. The quick summary that we have found out is that for 50 HP or 100 HP tractors, methanol turns out to be an extremely attractive option in comparison to diesel. The viability gap funding for that is hardly 3 to 4 lakhs on an NPV basis per tractor. But once we move to excavators and mining, the challenges are more because of the intense duty cycle that these things need. We cannot run on methanol because the energy content required to drive a mining or a construction equipment is extremely high. So what we have done is that we have explored various options. We started off by thinking that H2 CNG is going to do, but the benefits were quite negligible. We explored hydrogen ICE, where we are using the internal combustion engine and trying to run it 100% on hydrogen. And for us, we have found that intense duty cycle, it makes great sense to put that. But let's not limit ourselves to that. While we launch the report, I'm happy that we have a group of panelists out here who can give us much more innovative application. But that comes in just a moment's time. For now, I request our esteemed panelists to kindly just help us launch the report, and your blessings and applause is much needed at this time. Thank you.
Well, the session on green hydrogen and energy storage specialist, and Mr. Bhardwaj was here. We are going to be exploring innovation applications on green hydrogen, new frontier and use cases. And the key points we're going to be focusing: what are the innovative applications? What is the emission reduction potential across various initiatives? What are the infrastructure challenges? What are the cost reduction needs? And what are the policy and incentive support? Mr. Bhardwaj, I would request you to please moderate the session. Thank you.
Okay, so I think we can get right to the point, and starting from Mr. Lele. My request is, can you talk generally about new applications on hydrogen for both production and demand?
Thank you. Happy to be part of this session. I know we are running out of time, so I'm mindful of keeping time and stay brief. I will talk about two use cases which are not in the normal refining, fertilizer, steel, those kinds of segments. Two use cases that are very India specific is what I'm trying to point out at. One of them is in specialty and fine chemical industry. We are a global manufacturing hub recognized in the world as a country that produces a large amount of pharmaceuticals, agrochemicals, dyestuff, pigments, construction chemicals, and a whole host of those kinds of chemicals. These use hydrogenation as a platform chemistry. They require hydrogen today. At a country level, we do not even have a good understanding of how much hydrogen is required. But roughly my estimate is about, conservative estimate is about 100 kilotons per annum, which is not a very large number, but it's not a very small number as well. And I think it is a very conservative estimate. It could be possibly double the number. It's sufficient to bring in scale. Now, this reason this application is important is, it is very unique to India. We are manufacturers of these kinds of chemicals, but equally importantly, these chemicals are exported. 22% of generic drugs sold in the US markets come from India. They are manufactured somewhere in Hyderabad. 24% of what is sold in the UK comes from India. Okay, the same goes with agrochemicals. A very large amount of agrochemicals that are made in this country are sold in markets outside. And why this is important is because in many of those markets where it is sold, there is today a carbon price available. If I can show that I'm mitigating a ton of CO2 emission, I can today get a credit of anywhere between $80 to $100 a ton of CO2, which means, even if I buy hydrogen at a little higher cost, if it is green or clean, I'll be able to make some of it at least, if not all, by selling in markets outside where anyway I'm selling, and get the carbon credit for it. Okay, so this is a very interesting application which I don't think people are looking at. The second important part and very interesting part in this is these chemicals are today manufactured in hubs. You go to Ankleshwar, you go to Dahej, you go to Taloja, you go to Hyderabad. There are regions, physical, geographical regions in which all these companies are co-located, which solves the problem of hydrogen transportation, which is the most challenging problem. So if you were to make hydrogen in a hub where all the offtake demand exists, you don't have to transport and spend a whole lot of money in storing hydrogen at high pressure and transporting and so on. You could, in principle, just simply lay pipelines, which is the cheapest form of hydrogen transportation. Okay, or even if it is done through cylinders, it's only less than 50 kilometer distance over which you are transporting. So it solves that problem as well. So in multiple ways, this is a very interesting application for India that not too many people are looking at. And these companies are very interested in moving from gray hydrogen, which they use today. It comes from either methanol reforming or chloralkali plants, which they are using today. And they're very interested in making it green, because they can then use that chemical in markets where carbon pricing is important. So this is an interesting application that I think you should look at. If I have time, I could talk about it.
We always have a few more rounds, and then,
I'll come back.
So Raj, since you come from a very interesting American perspective, please tell us what are the new applications, and especially you spoke about SAF. What is it that we should do more in SAF?
Thank you. Yeah, I just want to thank everybody for coming, and thank Vivek and USAID for putting on this session. I think, first of all, from the Clearview perspective, we'd like to talk about two things when it comes to innovative applications of green hydrogen. And those two axes are first, business models and business cases, right? You need innovative business models and business cases to make green hydrogen work, regardless of the sector you're talking about. And the second axis is, of course, technical innovation, right? There are existing sectors that have hydrogen that use hydrogen already, and there are sectors that you can do fuel switching, right? Like mobility or aviation fuels, as we discussed. And I think the broad overarching point for considering the first business model access is that, in our opinion, every application of green hydrogen today requires an innovative business model. When you try to use green hydrogen in an existing sector like fertilizer, ammonia, refining, et cetera, your entire business case changes. The demand signals are different. The supply chains are different. The people you need to sell to are different. You need to sell into a differentiated product market now. And so given that consideration, it really narrows the scope of applications that can absorb this type of business model change, right? The applications that can actually find a way to change or adjust the way that they do business to be able to take on the excess cost and structure of green hydrogen. So given those sort of two axes, one of the most innovative applications that we see as having high potential for hydrogen offtake within the next 5 to 10 years is power to liquid SAF, and more generally power to liquid e-fuels, right? So green methanol for shipping as well. And I think our focus is on e-fuel SAF, power to liquid Fischer-Tropsch synthesis SAF, because there are key demand drivers and demand signals that we do not expect to change within the next 10 to 20 years. And so if we look from a policy perspective, the EU, the Renewable Energy Directive has already set out significant SAF mandates. I think it's 5% by 2027, and it grows from there. Those mandates also have power to liquid components, right? So someone will have to make power to liquid SAF, and the EU will have to buy that SAF. Similar mandates exist or are going to exist in South Korea and Japan. And the US is, of course, not a place where we do mandates, but we do sort of carrots instead, right? So there are incentives to make SAF. And so these incentives are really what we feel drive the business case of sustainable aviation fuels, particularly power to liquid. Now, for the India perspective, we see power to liquid SAF as a really key industry and a possible use case for green hydrogen because of the existence of significant point source carbon or CO2 emissions, right? There are already significant sort of natural gas power plants, ethanol plants, ammonia plants, refining plants, et cetera, that release carbon dioxide at with relatively high purity. The off gases have relatively high purity, and they do so with a constant flow rate. And so because of that existence of a CO2 source, you can put a carbon capture unit on top for, the cost estimates vary based on the facility type and where you are, but relatively cost effectively, you can put a carbon capture unit on top and use that carbon and combine it with green hydrogen, as Dr. Lele mentioned, hopefully co-located, so there's no transportation costs, to make sustainable aviation fuels, right? And so India has an existing CO2 base that it can tap into, and such that some of these bases are even close to sort of where the SAF would be used, right? In Gujarat or Haryana, you have significant CO2 point source emissions co-located to airport and aviation fuel transportation terminals, right? And so you can start to combine and define these business models in ways that make sense and are innovative and can offtake a lot of green hydrogen.
Okay. Anup, you come with a very unique perspective of liquid hydrogen. Yes. Kindly educate us, what is the business case for liquefying hydrogen? What are its advantages and challenges here?
Okay, sir, thank you. So from our perspective, INOX India is a prominent manufacturer of cryogenic equipment. So we have also been in this business and seen these similar business cycles for industrial gases such as liquid nitrogen or liquid oxygen. And very recently, we have seen this cycle happening for natural gas. There was natural gas in compressed form, piped natural gas, and then liquefied natural gas came into picture. So when we look at hydrogen, we feel that in the initial phase, there will be definitely the infrastructure is going to get developed based on gas, as it happened in the previous cases also. But due to the inherent challenges of hydrogen properties, which people are not talking about, the liquefaction factor will come into picture. So when we talk about hydrogen and its properties, hydrogen has one of the highest gravimetric energy density. So if you consider 1 kg of hydrogen, whether in gaseous form or liquid form, it contains around 140 megajoules of energy. But when we come to volumetric energy density, it is one of the lowest. So when we talk about, I'll just take a hypothetical example to highlight why we feel that liquefaction will come into picture very soon. So for that, let's take an example that we need to transport some amount of energy, say 1,500 gigajoules of energy from Chandigarh to Delhi. And I have a transport tanker of 20,000 liters. So if I have to meet that energy demand using diesel or petrol, I'll just require 3 tankers to transport from Chandigarh to Delhi. But if I switch the fluid to hydrogen, I'll require 27 numbers of trailers. And I'm not talking about 200 bar. Hydrogen, which is compressed to 350 bar, I'll require 27 numbers of tankers. So there is an increase of 9 times, right? That is the first challenge where you will come across capital costs as well as OPEX costs. The second factor is that if you are assuming that these vehicles are fueled by diesel, then again, you are increasing the vehicular pollution by 9 times. If they are fueled by clean fuel, even then there is a challenge because you are increasing the vehicle density by 9 times. So to find the middle path, if you look at the liquefaction, if you want to transport or meet that energy need using liquid hydrogen, you will be requiring about 8 transport tankers. It's about 2.5 times that of diesel, which is still high, but it is still manageable when compared to compressed gas form. So it is our firm belief, and based on our historical experiences, we feel that liquefaction of hydrogen will come into picture as we grow to scale in the market.
Yeah, so I think last but most important, I think the developers are the one who put in actual money, and we have Bidyut from Sembcorp and Mr. Gautam Reddy from Greenko, and it is requested that both of them give the developer perspective on how they see the market both as domestic and exports. Yeah, so I think same for both of you. Please help us in that.
Hello. Yeah, thanks Vivek, and good evening to all of you. Thanks to the previous speakers, everybody has gave a very unique perspectives of the hydrogen usage. Particularly if we look at the country's target for the hydrogen production by 2030, what we see, the target is at a quite a good decent level at 5 MTPA, vis-a-vis what Dr. Lele has said. For the small or imminent industry, smaller users is hardly 100 KTP. So there is a good gap. The gap has to be bridged by the major energy consuming sectors, which could be mass transportation, which could be big industrial usage, like some of the photos what we see in the mining, in the ships, in the mass transports, and also the other areas where the international other markets are targeting, such as Japan is targeting the power applications, etc. For the developer, the challenges is developer is basically bringing the sustainable energy into a usable molecule form, which means there are renewable green electron related production related challenges, which is by and far is a set technology in the world now, whether it is solar, whether it is wind. These are the two predominant technologies I want to mean. And also the storages such as battery, to some extent, it is a stabilized technology yet to be evolved, but basically to increase the technical commercial viability, there are other avenues are also being explored, like PSP, etc. The second part of it is converting the green electron into the green molecule. Now here comes the process, which is basically electrochemical process. So it is first electron goes and then the chemical molecule is generated. As a inherent characteristics of the process, it calls for a steady power supply, whereas the renewable has its own embedded nature of fluctuations. So this is where the developers' expertise comes into. The developers who are having the experience of doing the complex processes, which calls for continuous power supply, who have experience in renewable energy generation and managing the renewable energy within the optimum cost point, and also having the experience of dealing with the very hazardous molecules such as hydrogen, because hydrogen, as Mr. Shapeti has already rightly informed, it has a very high energy density when it is looked from the weight point of view. So it has its own hazards. So experience in dealing with the complex processes, very hazardous molecules, and also with the renewable. This is where actually the developer's valuation comes in. And the major consumption of the molecule can only come from the mass sectors, which by and far requires a steady supply. And that steady supply, if it is through pipes or if it is through other derivatives, it calls for a steady production, which means a steady process of generation. So this is what is the development challenges. In India, personally, I am very much hopeful, because with the abundant resources and the good government supports, we are finding many innovative technologies being every day being pursued. Apart from the set companies, startups are coming up in the storages. And ultimately, I am hopeful that India will be one of the market which will be one of the leading green hydrogen or its derivative supplier in the world in coming 4-5 years. So that is what my outlook. Yeah, thanks.
I request Mr. Gautam Reddy to speak again on the same lines as a developer.
Thanks, Vivek. It's interesting that you're talking of a lot of new age applications for hydrogen, but that as most of the world is not even adopting to the readily available demand, which is quite unfortunate. So that's where the whole conundrum lies here, that hydrogen can be used in multiple ways, but the market's not getting created. The developers are taking off, but multiple challenges on financing, on finding off takes, so on and so forth, right? So obviously there lies a challenge for all developers here. Slowly but surely things are moving. Obviously they're moving much faster in China. All these new age applications that we have seen talking about, they're actually happening there. I've personally visited a mine site in China where they're using hydrogen fueled earth movers and forklifts, which is really as advanced as it gets today compared to anyone else. So if really we can keep complaining about China, but if you have to catch up, then we need to move at least on the traditional sectors. And coming to that, if you look globally, around 90 million tons of hydrogen is used today, and almost 55% of it goes into refining. I think the first thing for the policymakers to do today, and there is really no excuse for that, is the global refining sector has to move to green hydrogen 100%. That will create a 55 million tons of hydrogen demand, which will create 350 gigawatts of electrolyzer capacity, and so on and so forth. Now, why we have this view very strongly is because converting this into a green hydrogen demand will actually affect the end consumer by a cost of fuel at the petrol station by 1.5 to 2%, depending on how much is the cost of green hydrogen. Even if you take a $5-6 green hydrogen, it's really not going to hurt the end consumers like, say, it would hurt an end consumer in, say, a cement industry if you turn to green hydrogen. So I think refining sector has to move. There is really no excuse for that sector not to move. But there are some countries that are moving. As you heard Honorable Minister today morning, India has already done tenders of 40,000 tons, moving to 160,000 tons in the next, in the refining sector here in India in the next 12 months. That's a very positive sign. Europe is obviously taken the lead. They have mandated 42% of their own hydrogen to be converted into green hydrogen in their refining sector. So these are very encouraging signs for developers like us who really want to create the scale, right? What we are attempting to do is to create hydrogen generation hubs, which are 90,000 tons, 100,000 tons at one location. And we have seen this. We've seen this in solar. We have seen this in wind. We grew up as a renewable company. We've seen that once you hit that scale, then industry surprises itself how rapidly the cost can come down. So pretty optimistic on that front, that technology and industry is moving. Demand has been behind a little bit. Obviously, there's a lot of inflationary pressures today in the world, and the general inertia of the traditional oil and gas industry to let go of the traditional ways of generating energy. But I think that shift is happening. Policymakers should move faster on that, but the developers also on their front have to take some innovative risks to make this happen. So it's a bit of a balance on both sides. But I guess I think by 2028, when the European big demand applications actually start delivering too, then there'll be a big shift that we'll see. Apart from that, I think there's other industries like especially shipping fuel. I think shipping fuel is clearly moving towards green ammonia. Retrofitting with green methanol is something great, but getting green methanol is very expensive today from green hydrogen, especially certified bio-green hydrogen that they need for methanol. So a lot of new ships that are going to be decarbonizing ships will go towards ammonia as a fuel. That's pretty obvious in how the market is moving today. So that's another application that will create mass scale demand to encourage developers to invest significantly into this. So these are some of the areas that we are looking at and are pretty positive and optimistic about.
Okay, thanks you. So I think in the second round, I think we can talk about incentives and policies. So you spoke about the chemical industry. What do you think are the incentives and policies that can kickstart hydrogen in the chemical industry that you spoke about? I mean, what do you think is needed? Is there a need for a scheme document, a subsidy? And I would like to ask this to every one of you. I mean, Raj, you spoke about SAF, you spoke about liquid cryogenic, and then, I mean, I have some questions for the developers. So in a very quick 30s, 40 seconds, what do you think is the policies and incentives for the chemical industry to kickstart the sector?
No, the reason I got excited about this particular application is because subsidies are not required. I do not think, markets, subsidies are okay to initially start the market, but not really good for us from a sustainable point of view. And the reason this is, I think, exciting is because, for chemicals which are sold in markets outside, as I said, there is already a carbon tax incentive that is available. You get carbon credits already, and that completely offsets any price difference between gray hydrogen and green hydrogen. Therefore, from the calculations that we have done, I really do not think a subsidy is necessary for transitioning from gray hydrogen to green hydrogen in this specialty chemical sector. Okay, that is why I got excited about it.
So I think for him, he says that the carbon tax, the EU ETS, is what will trigger them to incentivize uptake of green hydrogen, and that is the trigger point for the chemical industry. Raj, what do you think is the trigger point for SAF? I mean, is it mandatory, or I mean, what is the thing that will trigger it?
Yeah, I think at a baseline, it has to be mandates, primarily because India will have to compete with the other global mandates that exist already. On the point of mandates, India probably can't compete on a subsidy scale or an incentive scale, because we see already globally, the US has $8 billion in hydrogen hubs and billions of more dollars with these tax credits, specifically for SAF, ammonia, blue and green hydrogen otherwise, right? And so, an extra 2 billion, 3 billion, whatever it ends up being, for India to invest here will not help it compete globally in an export market. Domestically, you can change the structure with that type of investment, but globally, you can't compete by just adding, sort of drop in the bucket, 2 billion or $3 billion, as silly as that is to say. So as a result, I would say for SAF particularly, you need mandates, and that's coupled with what we're already seeing are significant demand signals from commercial airlines, right? So Delta, United, American, other international airlines are already buying SAF and are investing heavily in production facilities, right? So if you can couple that demand signal with a domestic blending mandate, India becomes more aligned with its global counterparties, right? And so these other airlines are more incentivized to come to India, increase tourism and just general flight commercial viability in India as well.
And I think that goes with the 1% mandatory blend for SAF, which might be upcoming in India from 2025. And I think that is part of the government mandatory thing, which might be extended to fertilizer or other things. So just waiting for the right signals. So same with you, Anup. What do you think is the trigger mechanism for people to get into cryogenic liquid hydrogen? Is it just the business case that will stand on its own legs, or do you think there is something else which is needed?
Sir, I don't have much to add to this point. My other panelists can add much, but I have one comment here. So when it comes to hydrogen, if you look at it from historical perspective, right, all the technologies or all the use cases were already developed and used before 1950. So today in the one of the other discussions where Tata Motors was presenting hydrogen use case for defense sector, they even showed us the pictures and the use cases where hydrogen was used in the defense sector in the World War I and World War II. So even though the technology was available in the past cases, hydrogen never became commercially successful because of three reasons: cost, availability of much cheaper fuels like fossil fuels were there, and hydrogen is pretty complicated to use in comparison to other fuels. So the trigger mechanism would come into picture when these three aspects are three difficulties are overcome, maybe through government support or technological evolution, and they are made more consumer friendly, right?
Okay, thank you. Yeah, thank you. I mean, I have a more tricky question to both Bidyut and Gautam out here. I think almost half of the demand for hydrogen comes in the oil sector. And if we say that the demand of itself of oil is waning, then are you going to have a firm business case for giving them hydrogen for the next, let's say, 25 years? I mean, if the demand of oil itself reduces and solar panels, you need a PPA for 25 years. So do you have enough demand, and are you sure that the oil demand is not already peaked and it will continue? They will continue to buy from you for the next your PPA period. I mean, what is your answer to that? Because a lot of developers are so excited about oil and gas sector. I'm compelled to ask this question to you.
Yeah. So look, for the oil sector, generally hydrogen most prominent use is in refining and desulfurization.
Yeah.
The targets of reducing the oil consumptions, while it is also phased over a time and in foreseeable future, we do not find that at least for 15 to 20 years of period, there is any drastic reduction or a disruptive change in the consumption. It is because of the simple fact that the other alternate solutions, they're either not techno-commercially that easily accessible, say for the EVs or the batteries, and they also come with their own challenges for the disposal, etc. So while oil, yes, there will be a steady downward consumption trend, but what gradient, that is for anybody's guess.
Yeah, Mr.
In vis-a-vis, if you see the other world trends, the subsidy mechanism for the major usages, such as transport specifically in Europe, or power in Japan or in Korea, the general market trends are always giving a subsidy for 15 to 20 years. It is not only for this case, for any technology case. Generally, the government always provides the subsidy support for 15 to 20 years to develop the demand. Once the demand matures, then naturally supply side comes to match up, because the basic theory of the market is if the demand is there, solutions will come in. So that is how it plays. It is, I think.
Yeah, thanks. Quite interesting. Mr. Gautam, please. On the same line.
No, I think we are far from that situation where you actually see oil and gas demand going down. I think it's we are very far from that, right? I mean, the world's consuming around 103 million barrels today. It's anyone's guess, 110, 115, and then petchem is around 30 million barrels, will go to 60 million barrels per day. So those numbers are there. I don't think that should be a concern at all at this point of time. Eventually, we have to decrease consumption of these fossil fuels, but I don't think anyone should be worried about that at this point of time, right? That's a far off situation. No, so I don't think so, right? I come from 20 years of upstream, so I know how much work needs to be done to replace something as big as that. It's not so simple. Yeah.
Okay, great. Yeah, so I think in the next quick round, we could ask a very quick question that what are the top 2 use cases you think would be, and then we'll have some audience questions also. What are the top 2 use cases that you think are going to be for hydrogen that comes to your mind?
In terms of volume or in terms of quickness of adoption in the market?
Business case is more important. Business case, there's a business case here.
Yeah, so without subsidy or with mandates, there are a lot of
minimum subsidy. I would say minimum subsidy, strong business case.
Yeah, so I think in terms of large volumes with mandates, clearly refining has to be because it gives volumes, and if mandates are there, it will be surely the one business case that should work out. But I did mention about one more case that I may quickly allude to. I talked about 100,000 tons per annum, 100 KTA case in the chemicals market. I want to talk about something that is 10x that. And again, something that we are not fully exploring yet. And this is about, consider the fact that by 2025, this country will have 900 people who use data, mobile phone carriers. The data demand, the data creation in this country is just, is going exponentially higher day by day, thanks to all the education, shopping, all the internet transactions that are happening, OTT platforms that are coming up. So data explosion happening in this country. There's also the drive to localize data, right? We don't want to take our data, send our data outside India. All that means is all this has to be done and this demand has to be catered to, there's going to be an exponential growth in data centers. The current estimate is about 3 gigawatts of power required for data center by next year, 2025, 3 gigawatts of power. This power has to be extremely reliable. Data centers just cannot turn off even for a microsecond. This has to be extremely reliable, high quality power. And this is not going to come from grid in the near future. There has to be an off-grid supply available for this kind of explosion of demand in data centers. There are already cases outside India where fuel cells have catered to data centers, right? So if you go by 3 gigawatts of power demands of data centers, do a rough back of the envelope calculation, you're talking of 1.5, 1.6 million tons per annum of hydrogen. Okay, so that's not a small demand, that's a large demand, and it's coming, right? At what price point will that hydrogen be available is the question. And I think the low-hanging fruit here is piped natural gas. It may not be green hydrogen, but it will be hydrogen coming from natural gas, which is still a good solution from a business case point of view, because it provides very reliable quality data center. And if some of that natural gas is substituted by biogas, which is coming up in a big way anyway in the country, to that extent, decarbonization will happen. Microsoft is running data centers on hydrogen as well, okay, but may not be a great business case in the immediate future. But I think data center power supply using fuel cells is something that we have not explored, but it's coming.
I think for you, it is electricity generation and blended hydrogen. Top 2 sectors. Yeah, Raj, simple.
Globally, I think the answer is clearly ammonia and refining, as the other panelists have pointed out. I think India is moving in the same direction towards ammonia and refining. I don't know that, especially in a global market, that India will be able to compete with, blue hydrogen or blue ammonia based production in the Gulf Coast in the US, right? Where they can use US production tax credits to produce ammonia cheaper, to produce blue ammonia that is cheaper than gray ammonia, and then sell that into export markets at prices significantly higher than they can currently sell gray ammonia prices, right? So India has to compete with that sort of bottom level use case on the global scale. And that's going to be difficult given, just where India is and the amount of incentives it has in front of it. As a result, what Clearview, what we are really looking into is sort of niche, longer term use cases that India can focus research and development on now to have an exponential growth effect later on, right? This is why we're talking about power to liquid SAF as a real application in India. If you can focus, X number of dollars now, you can have X squared or X cubed profit margins or sort of resulting impact in the next 5 to 10 years by developing these industries that aren't being developed in the same way with the same amount of money as they are globally.
Great. Yeah. So ammonia and oil. For you, where do you see your products going the best?
Sir, the most exciting sector looks to be mobility, be it aviation, train, onboard, off-board vehicles, or even marine. And when it comes to aviation and shipping, I think liquid will take precedence rather than gaseous hydrogen, because they'll not have access to intermediate refilling. So maybe liquid hydrogen will take precedence there.
Okay, understood. Yeah, because of the high energy density needed in the plane and a ship, you would put your focus more on shipping and aviation.
Yes, sir. And when India is talking about maybe exporting green hydrogen to other countries, and that would be mainly via ships, and they have to be fueled by clean fuel.
Thank you. And for both the developers, my request is also to talk about, apart from the top 2 use cases, what is the reaction of banks when you go to them for financing these projects? What is it that they ask? Are they comfortable enough, like solar, to give you long-term debt financing, or is it all equity? And plus the 2 use cases that you think are the best here.
I think the globally for the export-based contracts, banks look at the bankability of the project first, but still, I would say our experience has been that they are a bit conservative in terms of the tenure, in terms of the debt equity ratio, etc. So definitely the financial institution supports are required, but one important aspect what at least I have seen while talking to the financiers is they weigh the extent of subsidies given by the usage case as well as at the generation side. So supply and demand side, both sides, they try to gauge what is the extent of government support the industry is receiving. To that extent, they try to cover or assess the risk of the project. So that is one important aspect. And yeah, as of now, for compared to the other molecules, I find I echo the same what the other panelists have said. I think the ammonia is still the clear winner, whether it is transportation, whether it is other usages. Even for the fuel cell also, there are solutions coming in with the ammonia fuel cells. So yeah, that's it.
Yeah, it's not obviously it's not an easy game with financing these projects, but I think what bankers are looking at is innovative technical architectures, innovative technical solutions, and innovative business models also, where you basically de-risk your asset. So if you want to set up 1 million tons of green ammonia, let's say you have 5 gigawatts of solar and wind and everything else that comes around it. You all heard NEOM's case in Saudi Arabia. They've officially declared close to $9 billion of capex. Right now, if one company says, I'm going to take $9 billion of capex burden on me, and then fund it, and then there's no offtakes that are reflective of that kind of risk, then, bankers will struggle. So what you got to do is come out with innovative architectures, innovative collaborative solutions. Geography is extremely critical. For example, India, I believe that's why is very, very, very much at the forefront of this. In India, if you set up 5 gigawatts of solar and wind, you don't have to. If you do that in Algeria or Western Australia, for example, those electrons have nowhere to go. You have to make green hydrogen and green ammonia with them. But in India, if you set this up, then you can use that electrons to cater to the power market of India. Right. So even if you don't have a great green ammonia market, few years, you can use it. And that's 75% of the cost, by the way. It's not the capex that really affects this. So those electrons can then go and make serve the power market, which is 1.5 billion population growing at 9%. So you have to think of a multitude of things on how you can de-risk your project. How can you have a very innovative technical architecture and then the bankers get more comfortable. But yes, it's no one's case. It's not a walk in the park, right? Yeah.
And your top two applications that you feel?
Applications we already discussed. For me, I would even use the word, it's absolutely criminal for refining to not turn into green hydrogen. I think there should be a worldwide top G20 mandate that everyone has to go to green hydrogen. But if you just step back and think and look at coal, crude, and gas, right? Those are our primary energy sources. So where does green hydrogen come in and replace this? In coal, I think in Asia, power generation. See, India power generation, you can't replace coal with hydrogen. It's very expensive. But in Asia, power prices are a lot of times upwards of $250, right, per megawatt. So those applications, green hydrogen can go, co-firing with a coal power plant or even a hydrogen combustion engine, those things can work out. And I think that's why Far East, you see a lot of demand coming for hydrogen today in the power sector. That's about it, right? And then if you come to crude, see, mobility, yes, eventually, shipping and aircrafts, I think green hydrogen applications through SAF or green ammonia, green methanol will come. But if you look at global crude, only 8% of that actually goes towards these applications. 50% goes towards normal mobility, right? So that I personally think EVs will should dominate a lot more before hydrogen comes in specific markets, California, Korea, these places hydrogen works. And then I think, unfortunately, natural gas is where there's a huge substitution hydrogen can do, but natural gas is the cleanest fossil fuel there, right? So there is always this issue there. But eventually hydrogen will replace a lot of applications that today we use natural gas for, right? So refining, ammonia, all these are those applications. So I think that's how it will evolve.
Yeah, I mean, so before we go to the audience, quick take, any of you wants to take a quick take on CCUS?
So I'll make one comment. So CCUS is great. Everyone talks of 30-60 rule, though I haven't seen that happen. $30 capture, $60 sequestration. But if you actually see projects that were executed, it's going northwards of $200. So these are not easy, right? Number one. Number two, in CCUS, it's not the efficiency of what you capture. It's the upstream emissions of where the gas comes from. That is not part of a CCUS project, right? You point source emission, you capture carbon and say, I have captured this. But where is that gas coming from and what are the upstream emissions? If you go to US shale today, upstream emissions are up to 10%. And this is methane being emitted, right? And that's 28 times more carbon unfriendly than carbon CO2. So I think that's why if you really study this in depth, it's good in the short run. CCUS is good. Blue solutions are good. Everything that captures whatever is good. But eventually, I think if you really even need to achieve 2 degrees, if you're really serious about 2 degrees prevention of global warming by more than 2 degrees, you will have to go to green, right? Even you'll have to go to green. There's no other solution.
Exactly. And I think a lot of them are using it for EOR, the EOR recovery using carbon. We don't have that situation, too much situation in India, right? Yeah. So I think we can quickly go to the audience. Please go ahead, sirs.
Hi, I'm Prashanto, India Hydrogen Alliance. To Gautam's point on refineries, being criminal that they don't use green hydrogen. I mean, for our last frontiers, as it were, there are the two elephants in the room, refineries and fertilizers, accounting for 6 to 6.5 million metric tons of gray hydrogen. So, I mean, that seems to be a no-brainer that a 5 to 10% mandate in the near future. And not necessarily even of total production, but 2.5 million metric tons of imported gray ammonia. Any of that, if you shift, its transformation for the green hydrogen industry. So, isn't that a complete no-brainer? You don't have to look at a devastatingly radical thing of shifting everything to green for refineries.
No, we agree. I mean, it's what we've all been saying.
Hello, sir. My name is Hina Mandli from MNRE. My question is to Ashish, Lele, sir. Sir, when we blend two different densities of gases, generally its prices increases. So what's your point of view on that regard, sir? And my second question is to Anup sir. Sir, in the liquefaction of the hydrogen, there is a boil of losses. So what are the research and happening in the world to reduce that losses, sir?
Just want to clarify, you're asking of blending natural gas with hydrogen?
Yes, sir. So when we blend two different density gas, its prices increases, sir.
It's what?
Its price increases, sir.
Price increases as in because one of them is much more expensive than the other, but doesn't increase by the same token because the calorific value is also higher. Therefore, doesn't increase by the amount of hydrogen you are mixing with natural gas. Increases, but to a lesser extent because you are blending gas with much higher energy density on a gravimetric basis. The problem also is of pumping the mixture over long distances because you're decreasing the average density of the gas by blending. Therefore, you are pumping more volumes. Therefore, compressors have to work for higher capacity, and therefore your pumping costs go up. So, it's a compromise of all of these factors that come in.
Just want to add quickly to that question. So we all know that Maggie takes 2 minutes to make, right? So imagine if you had hydrogen blend to your cooking gas with 20% blend, you will actually take 10% more time, because for 20% more volume of hydrogen, the weight is maybe 2% more. And then what you actually get delivered is 2% more for the price of a 20% more gas. So you will end up spending more time on cooking because I mean you are basically burning it on the weight basis, not on the volumetric basis. Yeah. So that is another one thing that we have to think.
So to answer your question about boil off gas, I'll just take two typical examples. So when the LNG, that is liquid natural gas, is being transported over ships, right? The boil off gas can be used to run the ship's engine, right? Or there are liquefaction, small liquefaction plants, which again re-liquefy the boil off gas and put it back in the storage tanks. So for marine sector, similar applications for hydrogen can be also continued. And for aviation sectors, which is the other sector which is looking at liquid hydrogen with keen eyes, they are looking at developing different technologies. Just to make a case in point, there is a technology that is being talked about is cryocompressed. That is, they will not store the hydrogen in liquid form, but they will store it in gas form, but at cryogenic conditions, say at minus 230 degree or minus 233 degrees. So all these technology evolutions are happening and being studied by various companies. So in the longer run, I think boil off will come into control, but for cryogenic liquids, there will always be some boil off.
Hello, sir. Hello, sir. This is Dr. Prashant Ravi. This is for Dr. Ashish Lele, if I have a question, sir. So I work for Caterpillar. The example you used for data center, actually my company is the one that developed that for Microsoft in collaboration with Ballard. So it's good to hear that being spoken about in this forum and things like those. I have not heard many people speak about that example. Where do you see that in India as a potential option for fuel cells usage for data centers specifically?
As I said, I think I come from the premise that sometimes transporting molecules is easier than transporting electrons. From that perspective, if I have a natural gas availability at a data center, putting a solid oxide fuel cell to use that natural gas and produce electricity, which is a much better quality power supply that the data center requires, is where I would say is a business case. So you have a gas pipeline coming into your data center. You put solid oxide fuel cells, generate electricity to run your data center as a base load. And then you can, as a base load, and then use, if required, grid or maybe worst case DG set as a backup if really required.
We can talk maybe offline. That sounds interesting to stop.
Yeah, hello everyone. My name is Sajal Chakraborty and I represent a startup company called 1H1 Labs. My question is for Anup. and it is a hypothetical case of nuclear to hydrogen. I believe that a 30 megawatt nuclear plant would be maybe as big as, in terms of dimensions, as the podium on which the speakers are sitting. That's just on a humorous note. But yeah, and it's going to be clean, safe, and compact. In terms of hydrogen production and subsequent sales, the fastest way of generating the ROI would be the international markets and not the domestic ones. So let us say the hypothetical case from India to UK would be about 20,000 kilometers. And in order to ship this, could you just point out which would be a better option? A cryogenic wherein we lose 30% of the energy, or whether ammonia would be a good alternative?
Sir, a very interesting question. One aspect is hydrogen in mobility will be having limited applications, say, in the marine industry, aviation, for sectors in.
No, I'm sorry.
Okay.
I'm sorry. My question is not about mobility.
Okay.
My question is about shipping, about transporting the hydrogen from India to UK.
Okay.
In a ship.
Okay.
So would it be cheaper, more economic to use the liquid ammonia? To make ammonia, or to ship it via liquid hydrogen?
Okay. Sir, I don't have a direct answer for that. So it actually depends upon the technology, because the cost is comes from the technology that is being implemented, right? So if your use case in UK is of ammonia, then maybe ammonia shipping would be more cheaper. But if it is going to be reconverted into hydrogen and again transported inland, then shipping liquid hydrogen in the.
Yeah, I'm sorry, I'm continuing it a bit too far, I guess, but just the back of the envelope calculations, energy-wise, just the energetics of it.
Sir, we can take it off stage, because I'll need to work out something. So,
okay,
yeah,
okay, okay, sure.
Yeah, this is to Gautam, a very direct
Sir,
question.
we'll come to you.
Sorry,
Please carry on, sir.
Yeah, my name is Sushnato. So I just wanted to understand very curiously, what are the pain points for fertilizer companies to really, offtake green ammonia? I mean, is it a pricing issue, or is it some different kind of an issue?
See, fertilizer by nature serves farmers, and that's a very sensitive topic across the globe, right? Farming subsidies exist not just in India, but all across Europe, all across US. So then the governments are already incentivizing farmers with low-cost fertilizers. So if you substitute gray with green there, then there's a higher cost again that hits the exchequer. So you can't.
At what price point do you think they will be able to offtake?
I mean, typically, if you can give green for gray, then they'll say it's fine, right? But so I don't think that's going to work, all right? But having still said that, for a lot of countries, it's not about just the price. For example, India or a lot of Europe, they don't make the gas that is needed to make the gray ammonia. So they are importing urea from Saudi or Ukraine or wherever, right? So for us, the rationale should be, if we go from gray ammonia to, and we are importing 3 million tons of ammonia as well. If you go from gray ammonia to green ammonia, what does it create? You're not creating a gas field in Qatar or Russia or Kazakhstan. You're creating an upstream industry in India, solar and wind. You're creating FDI into the country. You're creating jobs into the country. So you might end up paying a couple of $100 more, but you will create a lot more wealth in the country of consumption. So which is why government of India, as well as in Europe, they are clearly moving fertilizer applications also to green ammonia, right? Whereas in some other countries, it could be a more difficult proposition where gas is cheap. In US, if you see Henry Hub is $3 gas. In India, gas is $11. So with a $3 gas based ammonia, it's very tough to substitute it with green ammonia. But in countries like us, where we are all importing either gas or ammonia, then it's a more easy, it's a very more easier decision to make. Yeah.
Okay. Please go there. So इधर से ले लीजिए.
Sir, we are talking a lot about the applicability of this the green hydrogen. Applicability in different sectors like the civil aviation, like the sustainable aviation with the fuel, or the shipping sector, or other sectors. Applicability is okay. At present, this green production of green hydrogen is expensive for the expensive. Then while we applying the green hydrogen, how do we take care of this? Technical feasibility is okay, but how to ensure that the economic viability or the sustainability is also ensured, and what are the factors that we should take care of to make the congenial environment for the ecosystem of the green hydrogen?
I'm not sure I understood, but I think if you're talking of economic viability, I think how will green hydrogen be adopted with economic viability?
How to reduce the prices and the applicability, okay, but the application is expensive.
Yeah, that I think like we've explained a bunch of things.
Ensure the balance between this price and this applicability. How we should ensure?
No, like we've all spoken about, this has to be scale, there has to be demand. So it's a cycle, right? It's like solar.
How to increase the productivity and how to reduce the cost?
So obviously technology is key. There's more and more efficient technologies coming. For example, we are all in alkaline electrolyzers. We'll go to SOEC and they'll consume less power, but they have to become cheaper. So there's a technological driven cost reduction. There's a scale driven cost reduction. But at the end, we also have to understand the cost of not controlling global warming is significant. So if you put the total cost of not doing that, I think it'll easily justify that. I think one policy changes that have to happen is if you look at a value chain of some activity, in most places, the effect of moving to green hydrogen is actually very minimal. There's somewhere in the link where it goes 70-80%. So that guy resists, right? He says, that's too expensive for me. For example, one of our clients is Arcelor. We were discussing with them. He was saying that, in steel, typically cost of steel, if it's say 40,000-50,000 rupees a ton, if I have an increase of 100 kilos of gray to green hydrogen, they roughly use 100 kilos of hydrogen in a ton of steel. If I use $2 more, that's $200 more, 15,000 rupees, we are dead. No steelmaker will survive a cost increase of 10,000-15,000 rupees. But if you take it to a car, right, it's a $300 increase in a car, the amount of steel. So if all cars are mandated to be made mandatorily green steel, a normal car in Europe or US is $30,000. Will he pay $300 more? He will pay $300 more. I don't think he'll flinch. So I think a lot of policy also has to move towards end consumer mandates. We keep talking of mandates in the within the value chain at a business point where it gets a little difficult. But at the end, absolute end of the value chain, like we said in refining, it will only cost 1.5% more, right? So if we make mandates at the end of the value chain, I think it will automatically cascade behind to lower and lower costs, and someone will make the move.
I think with this, we'll close the session. But, just to answer to this gentleman, somebody said that, look, prices will be expensive. But if we don't do that, we will be the only civilization in the in the universe that could not save itself because it was too expensive to save ourselves. Okay, so I think things will be expensive and we have to accept that. And any other questions, we are all happy to take it offline. And thank you for this great patience. And we hope that, we see you and meet again offline and discuss this further. Thank you.
That was indeed an amazing session, and the session was on exploring innovative applications in green hydrogen, new frontiers and use cases. We would like to extend our sincere thanks to Mr. Vivek Bhardwaj, of course, the Green Hydrogen and Energy Storage Specialist, USAID and SAREP, for amazingly conducting the session. And now we would like to extend a heartfelt thanks as well as honor our eminent speakers in the panel for their presence. Dr. Ashish Lele, Director, National Chemical Laboratory. Mr. Anup Shapeti, Senior Technical Manager, INOX. Mr. Raj Shane, CEO, CVS Strategic Partners. Mr. Bidyut Chakraborty, Vice President, Business Development, Green Hydrogen Business, Sembcorp, India. Mr. Gautam Reddy, CEO, Greenko. And I would now like to invite on stage Mr. Pavitra Barik, Scientist D, MNRE, to honor our moderator. He is here. Mr. Vivek Bhardwaj, thank you very much. I would request everyone to please come forward for a photo opportunity. It says when things go wrong, as they sometimes will, when the road you're trudging seems all uphill, when the funds are low and the debts are high, you want to smile, but you have to sigh. You know, when care is pressing you down a bit, rest if you must, but don't you quit. There may be so many difficulties in life, but we will not stop. We will definitely go forward for brighter and a better future. So ladies and gentlemen, thank you very much for being a wonderful, wonderful audience. Thank you very much, all the participants and delegates, our distinguished dignitaries, all the professional organizers, as well as our eminent speakers. Have a great evening. And of course, wish you all the very best for a brilliant and a brighter future. Thank you. And good evening.